Alright, so everybody's here. We can start our demonstration. Today I will take about 40 minutes to introduce the general process of mechanical design in ZW3D. And first of all, let's look at the interface. So it's quite familiar, right? It's just like SolidWorks. We have features for solid modeling, surface modeling, direct edit for parametric-free editing, assembly, and all the sheet metal weldment, PMI, and evaluate, and etc. And here I will introduce from part design to assembly design, and then 2D drawing, sheet metal, and weldment. Now let's start from the part design. Let's create a new part. And every design start from sketch. So now we create a new sketch. And here we can draw some shapes. For example, here we draw a circle first, and a rectangle then. Okay, and then we can use the power trim to trim the useless lines and circles. Okay. And then we can add some dimensions and constraints to make it well defined. First of all, we need to add some constraints. These and the center line to be symmetrical, and then we add the distance. It should be 270. Okay, now it's black color, means well defined, just like SolidWorks. Okay, then we exit the sketch and we call out the extrude command. Okay. And then we can continue to create more shapes. And we can also call the command first and then select the locating datum. Okay, now we draw another sketch. Okay, then we can add the dimensions. For example, here we add a dimension from this point to the center line, and we can add a normal dimension, or we can add the symmetrical dimension. Symmetrical, it should be. Here we accidentally snap constraint, not the way we want. We just delete it, and we add a dimension, symmetrical dimension to 130, and this length to be 100. This point to the center line should be 100. And the distance from bottom line to the center line, it should be 50. It should be 20. And this line, it should be horizontal. Okay, now it's well defined, and we exit the sketch environment, and we choose axis. Okay, now the second shape is already created. And after that, normally we will create some engineering features like holes, fillets. Now we can create the holes first. We can call out the hole command, and it can snap the special points. For example, the center line of the circle automatically, like this. And we can choose either simple hole, counter bore, and etc. In this way, we need a simple hole, and the diameter should be 200. Okay, finished. And also we can create some fillets. We can select the edges of the way we want. Okay, and the radius 2 is fine for us. Okay. And we can create more holes. This time I don't call out the hole from the ribbon area. It's not so convenient for me. I can use the mouse gesture. Looks very familiar, right? Just like SolidWorks. Okay, we choose hole. And this time the hole locating point is not very special, like the center point. So we can use the sketch for help, just like SolidWorks. And we choose the point, and we add the dimensions from the point to the center line 130. Okay, now it's black, well defined. Exit. And here we use the clearance hole, and we can choose different standard as we want. In this way, we choose ISO, and the size we use M20. Okay, finish. And now we have one hole, and then we can use the pattern to create a circle of holes. And also this time I don't use the ribbon area. I also make all the common used command in my mouse gesture, so I can activate very quickly. And we choose a direction Z. Okay, looks nice. And we can toggle the useless one, which is over the boundary. Okay. Okay, now the part is already created, and then we can continue to create the 2D sheet. And here you can choose the 2D sheet from the right menu. And also, of course, you can choose it from the DA toolbar. But here, I prefer to use the right menu because it's always context sensitive. Okay, 2D drawing. And here we have different standard integrated into ZW3D. And here I make a special one just for ZW3D. Okay. And here we can create the base views. For example, here we create a top front view first. And if you think this is too small, and you can adjust the scale here. For example, here we'll make it 3 for the scale, and projection view. Okay, and here we can also make like a section view from the right menu or from a ribbon. It's the same. Okay, maybe we can drop down a little bit. Okay, normally to make the view more clear, we will create an isometric view, right? So here we can also create my isometric view very quickly. And the scale, we can also make it a little bigger. Okay. And sometimes if you think the isometric view, the view angle is not the way you want, you don't have to go back to the 3D environment to create a custom view. Instead of that, we can use our very useful command, rotate view. It's a very handy tool to adjust the view in 2D drawing, into the environment directly. Okay, now it looks nice. Okay, finish. So now all the 4 view is already created, and then we can create some dimensions and annotations. So first of all, we can create this. Okay, we can create the diameter for the biggest boundary, and then we can continue to create more dimensions. Okay, and then we continue from the top to the bottom, and also the diameter of the hole. Can drop down a little bit. And sometimes if you want to add some like the tolerance, we can also just double click and we choose the tolerance belt. We can have a hole tolerance and also shaft tolerance just for different standards. And here we choose the H8, and the display form we use the traditional one. Okay, finish. And also we can add some like datum target, datum feature, and feature control. For example, here we set this plan as the datum, and we have different styles for the datum feature. Okay, and also we add more annotations. For example, the feature control. Here we use the parallel degree and to datum A. Okay, finish. And also here we have some holes annotated. Here we don't have to add the whole dimension one by one. We can use a hole callout, and we just select the view and also select one hole. It will create the whole callout automatically. Okay, so it looks nice. Okay, now the view, now the 2D drawing is already created, and then next step will be like export the 2D drawing. By the way, here actually you can see my technical requirements already here, because I made the template. Actually, just more than one. I create more technical requirements templates, so you can always drag to your 2D drawing as you want. You can make more of them. Okay, now the 2D drawing is already finished, and we can export to PDF or DWG for the manufacturing or for any purpose you want. And in ZW3D, we have a very useful tool. It's called multi-export. And here we choose the drawing we made just now, and we can export both PDF and DWG together. For example, PDF, we have some options like for the text, and even you can set the passwords for the PDF. And also for the DWG, we can set the different like the versions of the DWG, or whether you want DXF or DWG, something like that. You can always choose. For example, we choose a relatively lower version, so your supplier can always open it without any problem. Okay. Okay. And here we can choose to export to desktop. Okay. Okay. Okay, now we can have a quick check in the desktop and new folder 2. Okay, now this is the PDF. You can see everything is good. The dimension color, the annotation color is remain the same as the ZW3D environment. And also the DWG, you can open it in like ZWCAD or AutoCAD without any problem. Here I'm not going to show you. Okay, now the 2D drawing is also created. We can go back to the part. Now we just create the one part, and sometimes you have to make it like a serial part, right, or part family. In ZW3D, it's also very easy to make that happen. For example, here we can use the config table, and we just put the k dimensions into our config table. For example, now the diameter of the circle of the cylinder, we put it into the configuration table, and also the height of this part. And we can add more config tables here by copy config or new config. But I prefer another way. We can use the Excel to help us to do it quickly. For example, here I add more dimensions, more values for the diameter. For example, 302, 50, 25, and 350 for the diameter. And for the height, I add one more height for 150. Now, if we will get 2 multiply 3, we will get 6 combinations of the configuration. Let's see. Once I click save, and here you can see I have 6 immediately in ZW3D. And to make it more distinguished, I would like to put the color different. Okay, now finished. And here you can see we already have 6 different configurations. We can switch. Yes, you can see the dimensions, the sizes, the colors is different. Okay, we can go back to the original one. Okay, now you can see the part is already created, and then we can do the assembly. We go back to the top assembly, and I will open one sub-assembly to show you the assembly features. Okay, we open this one. Okay, now we have a sub-assembly, and we go back to the assembly environment. And here you can see all the features are here, like the insertion feature, constraints, edit, inquire, animation, exploded view, and etc. Later I will show you some of them. Okay, now first of all, we need to insert the component, right? Okay, we insert and choose the part we made just now. And then to make them more easy to constraint, we can actually rotate or flip a little bit. Okay, this way is good. Okay. And we select the mating faces. You can see as I select the 2 faces, cylindrical faces, it will recommend me the concentric constraints. Okay, and we add one more for coincident of 2 planes. Okay, and finally we add 2 faces to be concentric. Okay, finished. Okay, now the insertion is already done, and besides the component we design, and also we can insert the standard parts. And here you can see actually we have a very powerful toolbox, and including like ISO and DME, ANSI, and etc. standards, national standards. And also we have applications like Misumi trace parts and part solutions for more standard parts library, including national standards and industrial standards. We can insert from the folder, and also here we have a very handy tool to insert the standard parts. We call Smart Fastener. Like SolidWorks, they have the similar one. And here all we have to do is select the cylindrical faces. It will always find the correct standard parts for the holes. Okay, now finish. We click OK, and all the bolt will be positioned in the right place and with all the constraints needed. And after the design is finished, we can check if everything's okay. For example, we have to check the interference if there's interference. And if there is, you can use the edit to make it disappear. And also, let's assume the design is already finished, and we have to do the design review, or we have to make the user manual. Normally, we have to make some exploded view to make it more easy to understand. So here we have exploded view too, and we have auto exploded way. It's very easy to make the exploded view. We just select the component we want to explode, and the direction we want to explode, and the distance. We have a quick preview. Okay, now it will create like an automatic explode view for us. Of course, it's not perfect, but no problem. It's available for edit. You can edit each step, and also you can adjust the order of different steps to make it more perfect. But of course, we have to do some manual works. So we can combine the auto explode and the manual adjust together to make a perfect exploded view. Like here, I already made it. Okay, and also you can export exploded view as a video to show the assemblers in the working site to better understand the whole process of the assembly. And if everything's okay, like the design review is passed, we can send the product to our customer. And sometimes customers do not have a 3D application, so we can use the 3D PDF to send the product to the clients. And also, we have a perfect tool for this kind of situation. We can save our product as HTML. For example, here I'm going to show you. Okay, it's done in my desktop, and here you can see we have HTML, and the customer can open it with whatever browsers, like the mainstream Chrome or Edge or even IE. It's no problem to open the product we make. Okay, you can see, and in the HTML actually is not just the look at the general shape of the product. You can also hide and show some specific component to check more details of the product. And also you can explode to see all the components put together, and also the section view to check the internal details. Okay. Okay, now everything is good, and we can continue to create the documentations of the assembly. For example, the BOM, the bill of material, and also the 2D drawing. So for bill of material, we have two different ways to do it. First one is 3D BOM. So also a highlight feature in ZW3D. We don't have to go to the 2D drawing to do it. We can do it directly in 3D environment. And if you select one of the items, it will highlight it in the 3D environment. The first benefits for the 3D BOM is you can always inherit the attribute from another component. For example, here this material is not the way I want. I can just right-click and inherit the material from another component. Now you can see it's already created, and if you apply, it will write back to this part. So you don't have to open the part and edit the attribute. It's a much more quicker way for the attribute. And also we have the stock size command. So for part, you can calculate the stock size very easily. Now you can see all the stock size will be here. And if you have the per price, you can quickly calculate the total cost of this product. It's very useful. And also we have a very handy tools. It's a legend. You can see we can check the legend, the thumbnail of each component. So it's very useful. And when you export to Excel, the thumbnail will also remain there. So everybody will know which product is it. It's very convenient. And we can create the 2D sheet for the assembly. So besides the normal views, we can also add the exploded view here. Exploded view and the scale Okay. Okay, now it's created, and we can set the different view attribute. For example, we can hide the hidden lines, and also the thread line and the circles. Okay, now it looks tidy, and we can add the balloons. You can see automatically, and even you can choose, like you can make the balloon to be square or to be circular, just for better visual effect. Here we can use the normal one. Okay, and also the bomb. Similar like 3D bomb, we can also add the 2D bomb in the drawing. For example, here we add some attribute here, and also in 2D bomb, the legend, the thumbnail is also available. We put it in the first. Okay, and we use bottom right. Okay, maybe this one is a little bit big, so we can put it here. Okay, now everything's here, and the thumbnail is also here. Okay, now the assembly drawing is already created, and normally we have to create the drawing for each component, right? In this way, actually, we don't have to open part and create drawing one by one. ZW3D have a very powerful tools for this kind of situation. We call it auto drafting. Here you can see I can select 22 components together, and then we can set like a template just by one click, like we set them all to ZWSoft template. And you can select one file for each or all-in-one drawing. So I prefer all-in-one drawing, and also the view you want, like the common three views and the isometric view together, and whether you want the hidden lines, and even you can add the dimensions. For example, here I can add the horizontal dimension and the maximum dimensions automatically, and even the table for assembly. Okay. Now you can see ZW3D will generate 22 drawings just within 1 minute, very quickly. Okay, now it's finished. We can check now there are 22 drawings together just by one click. You can see each component will be here. Now you can imagine how much time it can save for the designer. Okay, now we already finished the part design and the assembly design, and sometimes we don't design for everything, right? Sometimes we receive the product from supplier or even from our customers. ZW3D provides very powerful translator for this kind of data exchange. So here we can check, we can insert the models from our suppliers. Now it's a SolidWorks model, and we open it. Now it will be importing into ZW3D. Okay, now it's finished, and we can put it here, and we start the constraints. Here, the first plan to be coincident to this plan. Okay, and the second one. Now here you can notice it will always tell you to save your file, just like SolidWorks. And then we continue. We add a concentric constraints for these two holes. Okay, now the basic position is already here, but you may notice like the hole is not match perfectly with the original structure. So in this case, no problem. We have very powerful direct editing tools for you to modify, like modify the product from the supplier, or even modify the native product. Here we choose to modify the product from our suppliers. As I mentioned before, we have a very powerful direct editing tools to make the parametric free edit. For example, here we edit here the dimensions to be 25 millimeter. Okay, and another side also 25. Okay, finish. And even if you think the thickness of the plate is too thin or too thick, you can also double click to make the thicker or thinner. For example, here we just make 5 millimeter more about the thickness, and also the radius you can also change it easily. For example, 1, 2, 3, 4. We just changed these 4 holes to be 8 for diameter. Okay, now it's already finished, and we can go back to the top assembly. Okay, now the fitting is perfect. And also, if this part is too long for you, you can also use the same way. For example, here we make it 15 millimeter for the length. Okay, and go back. Now it will be synchronized automatically. And if you pay attention to this machine, you can see actually there are a lot of sheet metals. So here I can also share with you how to design the sheet metal quickly in ZW3D. So first of all, we select the sub-assembly. We open it. Okay, now I will use this. I will redesign this to show you the process. Okay, we blank the original one, and we can create a new component. Okay, and here we can use our extrude tab command to create the base tab. Okay, we also use the rectangle, and here we can snap the intersection point of the frames. Sorry. Okay, and here we can actually hide the ghost faces to make it clear to see. Okay, now the plate is already created. We can continue to create the flanges. 1, 2, 3, 4. Okay. And you can see for the positions we have different choices. Normally I use this one in my company. And also the radius. For example, here we use 1 for the radius. And also for the corner, we can always close the corner for better welding. Okay. And we continue to create more flanges. And we can use full flange here. 1, 2, 3, and 4. And the length to be 20. And here you can see it will automatically resolve the inference area. Okay. And besides the normal flanges, we can also create the forming features. For example, the dimple, lower, and etc. And for lower, actually, ZW3D provides a very, very powerful tools to create it. For example, here I'll show you lower and the plan for the lower, and the sketch for the profile, and we just create a line. And we add a quick dimension for this line is 100 millimeter, and the dimension, the positioning dimension will be 50 millimeter. Okay, we go back. Let's see what will happen. Now you can see the lower will automatically generate it, and we can change the different sizes of the lower, and even we can flap the lower just by one click. You don't have to put the lower from the library and do the positioning. This one is much more easier and quicker. Okay, now you can see one lower is already created, and then we can use the pattern feature to add more lowers. Direction and 40, 10, 11, 12, 40, 100, 300, 1, 2, and we can make it symmetric. Okay, now you can see just by several clicks, we already created the lowers. And also for the dimple, it's the same logic. We choose the plan and the profile and create a circle. For example, it's 60 millimeter, and the dimension will quickly dimension the circle. Okay, finish. And you can see now that dimple is already created, and we can choose whether to be open or closed. And even the height is available for you to adjust. Okay, now it's finished. And after you finish all the sheet metal design, we can quickly check the unfold shapes, and also we can quickly export the flat pattern for laser cutting, for bending, etc. It's very convenient. Okay, this is a quick introduction for the sheet metal design in ZW3D. And then we go back to the top assembly, and I'll also show you how to design the weldment. For example, here we open a weldment. Like we can open this one. Structure, open. So in ZW3D, we have a very convenient command called 3D frame. So it will save you a lot of time to create the 3D sketch. You can see how it works. You can see. I just tell the system like what's the length, what's the height, and what's the width. And even I can add different. Even I can add more sections. For example, here I can add different. I can add 2 more sections, or here I can add 2 more sections in the Y direction. Okay, finish. Now you can see very quickly we created the basic frame, and then we can add the structure members to this frame. Before that, we can hide all of this structure member, and we just select all the edges we want, and we choose. You can see here we have a lot of member standards like ISO, DIN, GS, and even BSI. So here we can choose the ISO, and we choose a square frame, and I change it a little bit bigger. Okay, now it's already put it on the edge, on the curves, and even magic is we can add the joint in batch. Here you can see, once we click this, meter the joint, and the T joint will be created automatically. It will save you a lot of time, and we do the same for the bottom curves. We just use this way. Okay, and also the middle ones. Okay, finish. And here you can see we have some interference here, but no problem. We can use the end to face command, or we can use the T joint to do it. It's very easily. So I just select the structures in batch and the surfaces as the trim reference, and I'll do it again for the bottom. Okay, finish. And if you want to make some structure member bigger or different specification, you can also do it very quickly. You can use the edit structure member. 1, 2, 3, 4, 5, 6. Maybe this 2 as well. And the profile. This time we use the rectangle member, and the bigger one we make 200. Okay, finish. Now you can see very quickly we just change the structure members. And also sometimes we have to create some rib in the corner area, right? We also have the command to do it. Side plate, gusset, and all we have to do is select 2 structure members, and then adjust the sizes. This time I will just keep as the default to save time. Okay, now everything is already finished, and then we can use the structure BOM to quickly generate the buildable material for the structure frame. And here you can check all the available attributes here, like the cutting angles for both sides, and also the other attribute. And here you can choose whether to combine the same size structure members, and combine with different methods like overall procurement, or for cutting. So different purpose will have different combination results. Here we use the overall procurement, and also here you can switch to show the real mass, like the mass before cutting or the mass after cutting. It's very convenient. And finally, you can export to Excel. So everything is perfect for the structure design. And now the whole assembly is already created, and we can verify if everything is okay. For example, if the constraints is okay. Of course, besides the manual way to validate everything is okay, and also we have animation to do the verification. Here we can choose this sub-assembly here, and we can use our animation tools to create a more complete animation to check if the movement is okay and if there are some interference we haven't noticed. Okay, it's quite a complete animation that we can check. So the animation can contain a lot of elements. For example, the view change, view switch. You can see here a switch from angle to another angle, and also even I can set a different visual style, like the wireframe, like the shaded mode, and etc. And even in the animation, you can animate how the product is disassembled or assembled together. It's also no problem to do it. Like this, you can make the very detail. Now is the disassemble process, and also now is the assemble process. And even here, we can make it actually quicker. We can accelerate the play. And now you can see it will animate how the gear is rotated, and we can check how the mechanism is moving, and if there are some interference. Okay. And we also have the simulation tools for you to quickly check if your design is reasonable or not. So here we use this part as an example to quickly show you the process. Okay, now we have a part and a simulation, and we create a new structure static, linear static simulation. And the first process is to define the material. Here we can use stainless steel. Okay, and we add the constraints. In this way, it should be a fixed hinge. Okay, and the mechanical load, we just add a simple force load. It will be 10,000 Newton. Direction will be the negative y direction. And then we create the mesh. We have a basic mesh and advanced mesh. So this way we just use the basic mesh for quickly meshing processes. Okay, the mesh is created, and we can check if all the preparations already done. Okay, 0 errors and 0 warnings. We can start running the calculation. Now it's quite quick because we set the mesh size very big, like 10 millimeters. Okay, now it's finished, and we can check the total displacement. And here we can even animate the displacement when we apply a force to this part. And also the von Mises stress and the strain. Okay. And after that's finished, we can just have a report generated automatically. Apply a PDF. Now it's finished. Can open. Now we can check the report. Of course, the template can be defined by yourself as required. Okay, now that's all the demonstration from my side, and next we will have a Q&A session.